Hello and welcome. This short video is designed to help you better understand the specialized components offered by Spatial and how they complement our powerful data import, modeling, and visualization technologies. As the name describes, these components are more specialized and generally more focused on a given market segment. With that being said, let's take a look at what's on the agenda. This video covers the 6 specialized components available from Spatial: PHLv5 for hidden line removal, defeaturing, 3D mesh, advanced deformable modeling, 3D springback, and finishing up with advanced covering. Precise hidden line, or PHLv5, is a tool that generates hidden line data from a model based on eye and target locations. The data is stored on the model as line segments with given visibility information. Keep in mind that PHLv5 has no direct connection to any viewing technology. What I mean by that is that PHLv5 does not write out data to a scene graph for Hoops Visualize or OpenGL. Instead, it generates precise data from the geometry model and stores that data as a linked list of edges. The user can then use this polyline data to display the hidden line view in the end user application. PHLv5 works with manifold, non-manifold, and wireframe data. And it's easy to get started with thanks to a complete set of scheme extensions and sample code. Some useful applications of PHLv5 include engineering drawings, drafting, or advanced rendering within a 3D application. The next specialized component is defeaturing. Defeaturing is a tool that can be used to automatically recognize and remove features from your CAD model. It's configurable and works in a fully automatic manner, or the user can opt to use the tool interactively. Interactive use means that the tool will pause after it recognizes a feature, allowing the user to make choices from that point on. Supported features include 4 types of holes, chamfers, and both constant and variable radius blends. Here's an example of what the user can expect from defeaturing when used in an interactive mode. Another powerful component is 3D mesh. Using 3D mesh, users can easily create both volumetric and surface meshes from modeling data. Not only does Spatial provide a push-button solution in the form of a bridge that connects 3D ASYS Modeler to the Visual Kinematrix or VKI mesher, but users also have the option to work directly with the VKI library, allowing them access to all the power and flexibility of the mesher itself. The latest release includes many new features, such as an upgraded VKI library and new APIs that harness the power of cellular topology in 3D ASYS Modeler. These new features are accessed via scheme extensions which enable the user to get up and running quickly. Many applications which leverage a CAE workflow can benefit from the 3D mesh product. Starting with the original model data, the user facets the model and then seeds 3D mesh with the facets. Here we have an example of the resulting tetrahedral mesh. Advanced deformable modeling provides tools needed to modify ASYS surfaces. Surfaces can be modified by attaching material properties such as bending or stretching resistance, applying load conditions with different behaviors, and then solving for a curve or surface which satisfies the loads and smoothness conditions. Once this is done, the user can then apply the changes back to the 3D ASYS model. Although advanced deformable modeling can be used directly, Spatial provides 2 higher-level interfaces to the tool with our springback and advanced covering products. 3D springback is used to correct for predicted or measured physical springback effects in sheet metal or stamping applications. Using 3D springback, users are able to control the desired shape change. Another high-level interface to the advanced deformable modeling is advanced covering. This tool is both simple to use and configure. It allows a user to cover end-sided holes in a way that satisfies a given set of conditions. Although there are many uses for this functionality, one common use is for the import of problem data from another application. 3D interop will translate and heal a model, but sometimes the model is missing faces altogether. This is an example of when advanced covering can be used to generate these missing faces. Additionally, some CAE users may wish to simplify their models by removing a group of faces and replace them with a single face generated using advanced covering. Here's a quick example of the type of faces I'm talking about. In this example, you can see on the left an example of a complicated hole to cover and why advanced covering can be an invaluable aid in providing a method for addressing this type of situation. This covers specialized components from Spatial. Visit www.spatial.com to learn more about our portfolio of software development products. Here you will find Developer to Developer, the Spatial blog, as well as a host of other resources to help get you started. Thanks and have a great day.